In this lesson, we will learn how to identify whether a quadratic function has a maximum value or a minimum value. We will also learn how to compute such a value. But before we answer the exercises below, let us recall first some basic concepts about the graph of a quadratic function. The quadratic function given by f of x equals ax squared plus bx plus c has a graph known as a parabola which opens either upward or downward. If the leading coefficient of the function a is positive or greater than 0, then the parabola opens upward. If the parabola opens upward, the vertex with coordinates h and k is known as the minimum point. Now, if the parabola has a minimum point, then the function f has a minimum value equal to k. Now, if the leading coefficient a is less than 0 or negative, the parabola opens downward, and the vertex with coordinates hk is now described as a maximum point. And so if the parabola has a maximum point, the function f has a maximum value equal to k. So how do we find the maximum or the minimum value of the function? Recall that we have a formula for k, right? So we have k equals 4ac minus b squared over 4a. This is the formula that we're going to use to find either the minimum or the maximum value of a quadratic function. Now let us answer the exercises. Item number 1. We have f of x equals 3x squared plus 24x. Again, we have to identify first whether the function has a maximum value or a minimum value. Since the leading coefficient is positive, the parabola opens upward, so it has a minimum point. And so the function has a minimum value. Now let us identify the values of a, b, and c. A is equal to positive 3, b is equal to positive 24, and c is equal to 0. Using the formula k equals 4ac minus b squared over 4a, we have 4 times 3 times 0 minus 24 squared, all divided by 4 times 3. This is equal to 0 minus 576 over 12. So the numerator is negative 576 divided by 12. The answer is negative 48. So the minimum value of the function is negative 48. Let's have item number 2. We have f of x equals negative 2x squared plus 12x. The leading coefficient is negative, so the parabola opens downward and the parabola has a maximum point. So the function f has a maximum value. Let's identify a, b, and c. So a here is negative 2, b is positive 12, and just like the first item, c is 0. We have k equals 4ac minus b squared over 4a. Plugging in the values, we have 4 times negative 2 times 0 minus 12 squared over 4 times negative 2. So this is equal to 0 minus 144 divided by negative 8. This is negative 144 over negative 8, which is equal to positive 18. So the maximum value of the function is positive 18. Let's have item number 3. Now, the leading coefficient here is positive. So the parabola opens upward, and so the function has a minimum value. Let's identify the values of a, b, and c. A is equal to positive 2, b is equal to positive 12, and c is equal to negative 3. Using the formula for AC minus b squared over 4a, we have 4 times 2 times negative 3 minus 12 squared, all divided by 4 times 2. This is equal to, so this is 4 times 2, 8. 8 times negative 3, that's negative 24. And then minus 144, all divided by 8. So we have negative 168 divided by 8, which is equal to negative 21. Alright, so this is now the minimum value of the function. Let's have the last item. Okay, so unlike the first 3 items, the function in number 4 is given in vertex form. So we don't have to solve for k, because take note that if we have the vertex form actually gives already the value of k. Take note, the vertex form is y equals a, or f of x equals a, f of x equals a times x minus h squared plus k. So this one is already the value of k. Now, since the leading coefficient is, or the value of a is negative, the parabola for this opens downward. So this one has a maximum value. And so the maximum value is negative 7 over 6. So max value is negative 7 over 6.